Okay, should have just continued on, but I'm going to have you do these in the Zoom time, and this, and this. This will give everyone a little practice. All right, so then finally, let's come on to this, onto. So proving or disproving that functions are onto. So how do we do this? All right, here we go. So you know that we have to say for every y, there is an x such that f of x equal y. Okay, so what you're going to be doing is this kind of little scratch work to make this contrived value. So here we go. So f of x is equal to 4x minus 1. Is this onto? So if I'm going to show that it's onto, what I have to show is that for every y in the reals, right, I'm starting in here, there is an x in the reals, right, this one, such that, right, f of x equal y. Okay, so this is what I'm going to say to do. It's not going to be very much, but just this little bit of scratch work over here. So what I want to do is I'm looking at this y equal 4x minus 1. So I want to find out what does the x have to look like. So, whoops, I'm going to add 1 to both sides, and then I'm going to divide by 4. So this is the contrived value for x. So I'm going to say, okay, come over here. I'm going to say pick x is equal to y plus 1 over 4. So then f of x equals, right, because I want to say this is going to be true, put this value into the function, right? So I put 4, and then in for x, I'm putting this, right? Y plus 1 divided by 4 minus 1. Okay, so I cancel the 4's. Y plus 1 minus 1 equals y. Check, I got there. So it said no matter what the x is, I'm sorry, for every y, I can find an x so that f of x equals y. So for every y, I can find an x, and this is, I'm telling you what the x is that'll get me to the y value. All right, so let's go over to this one. Is this onto? So let's remind ourselves of the difference between reals, which would be like this, right? This will be a y-axis, x-axis. Reals include all numbers, right? Okay. On this is integers only. So what does a picture of integers look like? So when I plug in 0, I get -1. When I plug in 1, I get 4 minus 1 is 3, right? I get this. So look at that. I've got dots, right? So it's just integers, and I'd have numbers back here too, right? So -1 minus, or -4, so I get down here at -5. But look at this. I just have this. So this is not onto, right? Not every integer is going to get hit. So let's think about an integer that's not going to be hit, that's in the range or the codomain. So 0 just goes easy, right? 0 is an element of the integers in the codomain, right? Is there an n in the integers in the domain one, right? So what I'm thinking of, such that f of n goes to 0. So that would give me 4n minus 1 is 0, 4n is 1, n equal 1/4. Oh, that's not an integer. So not an integer, so no. So this shows it's not onto, right? I don't hit all integers. So that's what you give an example, right? The counter example is I picked an element in the codomain, and go easy, right? Pick something like 0 or 1, and that will be nice. All right, so I want you to practice with this. It's going to be fun. And then I want you to do this one and this one as well. And then, oops, I thought I have a whole extra page there. Example 13, I guess I pulled up an old file where it says fill in the blanks. And I want you to do all of those on Zoom as well.